started. Let's review what transformations are. We just got back from Thanksgiving, so let's just go over all the vocab and all the good stuff we learned. So transformations are a change that is happening that changes the position, shape, or size of a figure. So the three that we focused very heavily on were reflections, translations, and dilations. And this is the key vocab right here, coordinate notation, that you will have one of your mastery standards on being able to use coordinate notation with the transformations. Okay? So coordinate notation is just the rules that we've already been using. So you kind of already have been doing this. But we're just going to focus on that today mainly. And we start with this rule to show the transformation. And the input is the points from the pre-image. Okay, so all the points on the triangles that we have been transforming start with the original points from the original triangle, the pre-image. And then we transform it right here with this arrow, and we have an output. And based on whatever transformation you have, your output is different because we have three different transformations that we've been focusing on. So those are going to be the output points for the image, okay? And we should be familiar with those vocab words. Whenever we use prime notation, that's the apostrophe that we use to label the image point. So remember, we always start with the original as the pre-image right here. And then we do the transformation and we are left with an image, which is after the transformation. And we use those prime notations after every point on the triangle. Okay, so this is just a review on that. We've been seeing this for a while now, so let's move forward. Reflections. Remember, reflections are a mirror image of the shape across the line of reflection. And we have 4 different lines that we've been focusing on in my class. So across the x-axis, across the y-axis, across y equals x, and across y equals negative x. And these are the rules that we've been using. Each one is different. But the main thing we need to remember is that negative means change the sign of the number of that coordinate. It does not mean that it has to be negative. It means change the sign. Okay, so let's practice using this example. It says, use the rule xy is transformed to negative xy. Okay, so we can graph the image. So they gave us the original right here, this triangle. And we want to use this rule, okay? So who is changing? Based on the rule, who changed? The x. The x is going to change its sign. You see that negative there. So I'm just going to start by naming the points first and finding those coordinates. So let's start with z. Z is at -1, 2, -3, 4. H is at -1, 4 on my grid. And G is at -1, 0. Okay, so those are the original. And now I'm going to transform all of them and make all the x coordinates opposite signs. So the new z prime is going to be not -3, but it's going to change to a +3. The new h prime x coordinate is no longer -1, it's +1. And the x coordinate for g prime is now going to be +1 as well. So I went ahead and changed all the x's using the rule here, this rule that they gave me. Okay. And the y's stay the same. Nothing happened to the y's. We're going to keep them the same. So 4, 4, and 0. So these are the new coordinates. These are the new coordinates for the image. And now we can plot it. 3, 4. 1, 2, 3. Use a different color. 1, 2, 3. So z prime 1, 4 is H prime, and 1, 0 is G prime. Okay, and then we just connect the dots. Thank God for my iPad, because I cannot draw straight lines. Oh my God, never mind. Okay, let's try again. All right, whatever, we don't have to be perfect. Okay, there's a triangle. All right, let's move forward to translations. Translations is the slide in the transformations that we've learned. So we're sliding the triangle left, right, up, or down. Remember, we're reviewing what we've learned before Thanksgiving. So here on this picture, this is the one we did on our notes. There's a change happening. We are moving up 1 and then left 4. And that is what happened with every point. It went up 1, left 4. Same for the A, up 1, and left 4. And that's how they all moved, and that is part of the definition. All points have to move the same distance in the same direction, okay? And these are the rules that we've learned already. So we have our mapping rule, and we know that the x-axis is the one that allows us to move left to right, and then up or down. And since this is a very straightforward rule, let's go straight into the example, okay? And notice I'm using the same triangle that we used for the reflection, okay? So actually, since we already know those points, let me just copy and paste them. These are the originals. Oops. Let's go back. No. Copy, paste. Okay, so here are the original points, and the rule says use this rule and transform the points by adding 2 to the x and subtracting 3 to the y. So what does that mean as a transformation? Remember, a positive x over here means that we're moving to the right. So we are going right 2 units, and then the y is a -3, so that means we're moving down 3 units, okay? So you can either do that directly on the grid, or you can do that algebraically by just adding 2 and subtracting 3 from the numbers. Since we have a grid, I say we use it so that it's easier to count on the grid. Let's start with Z. So right 2, so 1, 2, down 3, that would put me right here. H, right 2, down 3, right next to the Z. There's H prime. And then G, right 2, down 3, puts it in this new position, G prime. So there's the new triangle. We moved it. I'm not going to try to make it straight because it didn't work last time. All right. And what are those new coordinates? Let's just write them down. Z prime is now at -1, 1. H prime is now at 1, 1 on the grid. And G prime is now plotted at 1, -3, okay? And that is how we do translations. And the last transformation is going to be dilations. This is going to be the one that we are going to, okay, never mind. Let's completely ignore this definition. That's the wrong definition. Dilation is the one that makes the figure larger or smaller, okay? Ignore my typo right there. I did not read it beforehand. Okay, so these are the notes that we already filled in, and this is the example we did on our notes where we made the original triangle larger. And remember that for dilations, we have a scale factor, and it's K. K is the scale factor here. And we have two options, okay, because the third one is just the image stays the same. If your K value is a number that is less than 1, so we said those would be like fractions, then you're going to get a smaller image after you transform it. If your K value is greater than 1, then you would get a larger image after you transform it. And when we do our mapping, our coordinate notations, we multiply the x and the y with that scale factor K. All right. One of the tricks that I said to some of my students who were having a little trouble figuring out the scale factor, the scale factor is always going to be your new point divided by the old. We just use those words to make it easier. So if you don't know what the scale factor is, this is the formula. You're going to divide the new point divided by the old point value, and that'll give you the K. Okay, so just remember that as you complete some of the questions. For this example, we're going to be using the K value of 1/2. Okay, and again, we already know the original points for that triangle because we did it. I'm doing the same triangle. So let's just copy and paste the original. Okay, so those are my original points, and every point is going to be multiplied by 1/2. Okay, so for this one, I say we actually do the multiplication algebraically rather than trying to guess on the grid, since it is multiplication. So what is half of 3, negative 3? Half of negative 3 is negative 1.5. Half of 4 is 2. So what I'm doing here is I'm multiplying by a half for each one. All right, let's do h prime. Half of negative 1 is negative 0.5. Half of 4, we already know, is 2. And same here for G. Half of negative 1 is negative 0.5. And anything times 0 is 0, so that one stays the same. All right, those are my new points. Let's plot them. Z prime is at negative 1.52, so right about there, Z prime. And H prime is at negative half 2, so about right there, H prime. And G prime is in that same area, but at 0, negative half, 1/2, 0. That's G prime. So clearly, this is going to be a scale factor that made our image smaller because it was a fraction. Any number less than 1. Remember, fractions don't have to always look like fractions. That's why I did decimals here, because a decimal and a fraction are the same thing. So just remember that. All right, so those are the 3 transformations. Make sure that you answered all the questions and that you complete it. This Edpuzzle is going to be for a grade. All right, and have a good rest of your day. Bye.